Did you know? The moon is pulling away from the Earth due to a combination of tidal forces and the conservation of angular momentum. Let's break it down in a step-by-step explanation. Tidal forces. Tidal forces are caused by the gravitational interaction between two celestial bodies. In the case of the Earth and the moon, their gravitational pull on each other creates tidal bulges. These bulges are the result of the moon's gravitational force being stronger on the side of the Earth closest to it and weaker on the opposite side. Tidal friction. The Earth's rotation causes these tidal bulges to move slightly ahead of the moon's position. As a result, the gravitational force between the moon and the bulges creates a torque or twisting force on the Earth. This torque acts to slow down the Earth's rotation over time. Conservation of angular momentum. According to the principle of conservation of angular momentum, the total angular momentum of a system remains constant unless acted upon by external torques. In the Earth-Moon system, the moon gains angular momentum as the Earth's rotation slows down. Transfer of angular momentum. As the Earth's rotation slows down, the moon gains angular momentum to compensate. This transfer of angular momentum causes the moon to move into a higher orbit. In other words, the moon drifts away from the Earth. Increase in lunar orbit. The moon's movement away from the Earth is not a visible process because it occurs gradually over a long period of time. On average, the moon is receding from the Earth at a rate of about 3.8 centimeters, 1.5 inches per year. Over millions of years, this adds up and causes the moon's orbit to become larger. Gravitational potential energy. As the moon moves into a higher orbit, it gains gravitational potential energy. This increase in potential energy is balanced by a decrease in the kinetic energy of the Earth-Moon system. Essentially, the moon's orbital energy increases as it moves away from the Earth. Historical confirmation. The idea of the moon moving away from the Earth was proposed by Edmund Halley in 1695. The hypothesis was later confirmed by precise measurements made using laser ranging experiments during the Apollo moon missions. These experiments involved bouncing laser beams off retroreflectors placed on the moon's surface by the astronauts. Future implications. The process of the moon moving away from the Earth is expected to continue in the future. However, it occurs over such a long time scale that its effects are not significant in the context of human life or Earth's immediate future. It is estimated that the moon will continue to recede until it reaches a point where its rotation and orbital period are the same, resulting in tidal locking. In summary, the moon is pulling away from the Earth due to tidal forces created by their gravitational interaction. As a result, the moon gains angular momentum from the slowing rotation of the Earth, causing it to move into a higher orbit over time. This phenomenon is a gradual and ongoing process. However, the moon will not leave Earth's orbit. The moon's gradual movement away from the Earth, known as lunar recession, does not imply that it will eventually escape Earth's gravitational pull and leave its orbit. The moon's distance from Earth is increasing at a rate of about 3.8 centimeters, 1.5 inches per year. However, this rate is not sufficient for the moon to break free from Earth's gravity and wander off into space. The gravitational force between the Earth and the moon keeps the moon in a stable orbit around our planet. While the moon's orbit is gradually expanding, it will continue to orbit Earth for billions of years to come. The process of lunar recession will continue, but the moon will remain bound to the Earth's gravitational field. If hypothetically the moon were to leave Earth's orbit and move away into space, it would have significant consequences for both Earth and the moon. Tidal effects. The moon plays a crucial role in stabilizing Earth's rotational axis and moderating its climate. Without the moon, the Earth's axial tilt could become more variable, leading to extreme climate changes and potential disruptions to ecosystems. Tides. The gravitational interaction between the moon and Earth creates tides in our oceans. If the moon were absent, tides would be significantly diminished, altering coastal ecosystems and affecting marine life that relies on tidal cycles for reproduction and feeding. Night sky. The absence of the moon would dramatically change the appearance of our night sky. The moon is a prominent celestial object that provides natural light during the night and helps to define the phases of the lunar cycle. Its absence would leave the night sky darker and devoid of lunar features. Human influence. The moon has played a significant role in human exploration and scientific understanding. The absence of the moon would remove a crucial celestial object for astronomical research and could potentially impact future space exploration endeavors that rely on the moon as a potential launch point or research base. It's important to note that the moon leaving Earth's orbit is highly unlikely to occur naturally. The moon is gravitationally bound to Earth and would require an enormous external force or event, such as a massive impact or the influence of another celestial body, to dislodge it from its current orbit.